All right, so sometimes when you're dealing with balanced chemical equations, you're going to want to include the amount of energy that's either being absorbed or released in that reaction. So we're going to call those guys thermochemical equations. And they're balanced chemical equations that include the physical states of all reactants and products, which they should always have, and the energy change, or we're going to call this delta H, or enthalpy change. Okay, so I have on the board several different types of reactions and I've also included their enthalpy changes or energy changes in this. So we have our first reaction, which is just a simple combination reaction or synthesis reaction. And notice that the delta H is 1625 kilojoules, meaning that's releasing that much energy into the atmosphere. So when these two guys combine and form our rust, we're releasing 1625 kilojoules of heat. Okay, great. We also have a reaction, or this is actually a solubility reaction, where we have a substance, ammonium nitrate. It's being dissolved in some water and breaking up into its ions. And it's actually going to require some energy, 27 kilojoules of energy. You notice that there's no negative here, telling me that I'm requiring that much energy to make this reaction take place. It's an endothermic reaction. Okay, great. Then we also have combustion reactions. All have been, we're going to actually denote that as delta H COMb to say that this is a combustion reaction. Okay, so we have our glucose combusting, and we're saying it's releasing 2808 kilojoules of heat. It's a lot of energy when combustion reactions occur. And we're going to that little COMb is just telling me this is delta H of a combustion reaction. Down here we have phase changes. Phase changes can also go through energy changes and require energy or release some sort of energy. So this is water going from liquid to a gas. It's just a simple phase change. And it's a vaporization phase change going from liquid to gas. It's vaporizing. So we're going to denote that as delta H VAP, telling me that this is a vaporization enthalpy. And it requires 40.7 kilojoules of heat. And then also we can talk about, we specify formation reactions, meaning that I'm a compound or substance being formed from its elements. So we have hydrogen gas combining with sulfur to form hydrogen sulfide. And we're going to say delta H, and at that FORM is telling me that this is a formation reaction, and it requires 33 kilojoules of heat, is to endothermic. So we can get, just from looking at this basic equation, our thermochemical equation, we can get a lot of information from this. And these are basically all the different types of thermochemical equations that you're going to come across.